Hello and welcome to the Daily Space for today, Monday, March 30th, 2020. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. It is spring, and as we all shelter in place, the excess of daylight is easy to miss. It seems only fitting that in this dark time, we should take a moment to talk about dark matter. Now, when we look out at the motions of large and larger objects, we see behaviors that can only be explained if there is more material out there than we can see without telescopes. Discovered by both Vera Rubin and Fritz Zwicky, who were looking respectively at galaxies and galaxy clusters, today we know that at least 25% of the mass energy of the universe is hidden in this mysterious stuff. Initially, it was hoped that if we just look harder and in new wavelengths, we'd uncover this stuff in the form of gas, dust, black holes, and rogue planets. And when I was in graduate school, the emptiness of our universe and the scale of this problem was brought home to me when Professor Don Winget pointed out that you could account for all the dark matter in the universe by placing one Acme brick in each solar system-sized volume of space. That's not a lot, but that's enough. Our universe is seriously empty. And we're looking for stuff that adds up over the size of the universe, but in general just isn't all that much stuff. In the 1990s and early 2000s, teams searched for black holes and other dark objects that might be hiding out in plain sight. Specifically, they looked towards the galactic bulge and towards the Magellanic Clouds, and looked for the gravity of nearby objects to gravitationally lens the distant stars and make them temporarily seem brighter. While these projects did see gravitationally lensed things, including at least one planet, they didn't find nearly enough stuff to account for all the dark matter effects we see. At the same time, observers were ruling out normal things being dark matter. Other astronomers were thinking through how clouds of particles could gravitationally reshape images of distant galaxies, allowing us to look for dark matter particles that were nothing more than just a cloudy distribution of otherwise invisible stuff. And you know what? This is what we found. The bullet cluster image is perhaps the most famous example of how dark matter has been mapped out by looking at how it reshapes our view of what lurks behind it. In this image, you see in an optical series of images taken by the Hubble Space Telescope the galaxies that make up this region of space. You see in purple the X-ray emission of where, all the hot gas is. And that pink, that is a map of where background objects have been, gravitationally reshaped by dark matter. That's a map of where those invisible particles are. And the only thing is, these particles don't seem to interact through the electromagnetic force in normal ways. They don't produce or interact with light except by gravitationally tugging on photons. We don't have reason to think that dark matter interacts with magnetic fields. And in general, most of our normal ways of seeing things are defeated by dark matter. And dark matter's way of hiding only makes us want to find it all that much more. And astronomers and physicists around the world are struggling to find new ways to detect particles from dark matter. In a new study from collaboration by folks at the University of Michigan, Lawrence Berkeley Labs, and UC Berkeley, folks have sought to see if maybe mysterious flickers of light from nearby galaxies might be caused by dark matter. These flickers are only found so far in massive systems, and they're believed to possibly be, or at least they were believed to possibly be, from a theorized particle called a sterile neutrino. And they appear as X-ray flickers. Now, it was thought that the decay of sterile neutrinos might be producing this light in a very specific X-ray color. And this begs the question, of course, what is a sterile neutrino? And here I have to say, we have no experimental evidence that requires that these particles to exist. And there are no really good explanations of what they are to be found on the internet. So here goes with not perhaps the best explanation. Most observed particles in the standard model come in different varieties that have complementary spin. Now, I don't mean to tell you that the particles are actually spinning. They may actually be spinning. But what I'm talking about here is the word spin as applied to one of the observable characteristics of particles that we've just decided to call spin because why not, and let's confuse everybody. Astronomers and physicists should not be allowed to name things. Anyways, spin is categorized as left-handed and right-handed. And particles generally come in both sets of spins. And the thing is, all the neutrinos that we have observed to date are left-handed in how they spin. Now, sterile neutrinos are theorized as the right-handed spin version of this really hard to study little tiny particle, a particle that acts an awful lot like dark matter in terms of really not interacting with things. It was hoped that the sterile neutrino would prove real and prove to be at least part of the solution for dark matter. Now, analysis of data from the XMM Newton X-ray Observatory, looking at the flickers in large galaxies, they're there. These flickers are consistently there in large galaxies. And so it was hoped that if these flickers are caused by sterile neutrino decay, and if we're seeing this readily in big galaxies, and it's caused by dark matter, which exists even more in large galaxies. Large galaxies have more dark matter than small galaxies because they have more matter. It was hoped that this should mean that smaller galaxies like our own Milky Way, which have less dark matter, should have the same flickers, but in proportion to the size of our galaxy, which would be why we don't already see it. And we also don't see it because we're in our galaxy, which makes it hard to see these kinds of things. Anyways, it was hoped that we could detect this. And we didn't. By going through all the old archival images from XMM Newton's X-ray data, this team of scientists searched near and far in our Milky Way, looking in fields where folks were looking at isolated X-ray sources that were just a small part of the image. And in looking for these flickers, they found no flickers. And this indicates that whatever causes those flickers in massive galaxies is unique to the environment of those massive galaxies, and dark matter is not unique to massive galaxies. Therefore, these flickers are not related to dark matter. So dark matter can't be linked to the flickers, but we may still be able to blame sterile particles, sterile neutrinos, for dark matter. But we can't blame sterile neutrinos decaying on the flickers. It's all very complicated and amounts to, we still haven't seen sterile neutrinos. We don't know if they're decaying. We don't know what these flickers are. We just know our galaxy isn't flickering. Yeah. Coming up with and then finding new particles like these sterile neutrinos is very much at the heart of the quest to find dark matter. The coming up with particles part is easy. Math makes it possible to define all sorts of things, especially if you use string theory. It's the finding of these particles that is hard. But things that are hard aren't necessarily impossible. Everything in our universe is made up of particles and energy. Regular matter is made up of fundamental particles like electrons and composite particles like protons that are made up of combinations of 3 quarks. As far as we know, all stable particles are made of 3 and only 3 quarks. But quarks don't have to come together in only groups of 3. And we don't necessarily know about everything that is out there. Using massive particle colliders like CERN, researchers have been able to slam together bits of regular matter with so much force that it turns into almost pure energy that then recondenses into a myriad of stable and unstable particles. And in these flashes of particles, configurations of 4 and 5 quarks have been discovered. It's now theorized that 6 quarks may be able to come together to form stable particles. Called hexaquarks, these undiscovered particles are being actively sought as a dark matter candidate. Researcher Glenn Farrar at NYU has theorized that these particles may be trapped inside various elements in the crust of the Earth, such as oxygen-18. And there are literally researchers out there weighing different oxygen-18 atoms to see if they can measure the excess weight that might be caused by hexaquarks. Folks are also looking through the results of past particle collisions at the world's various accelerators. And there are hints of a large particle in data from Germany's WASA experiment at the COSI particle accelerator. It looks like there might be a 2.4 billion electron volt particle. And this is consistent with a 6 quark particle. It isn't conclusive, but it's a hint. And this is the best we've got right now. Other researchers are also looking for flickers in neutrino detectors that aren't caused by neutrinos and could be dark matter. And others are simply brainstorming new possibilities. But no one can really say exactly what dark matter is. Maybe it is a hexaquark. Maybe it is sterile neutrinos. Maybe it's both. The best guess we've got, based on observations, is dark matter is a particle that is a pain in the expletive to find. And yeah, that's all we've got. Not even dark matter wants to hang out with us in these dark times. Now, while dark matter may not be showing up for the shelter-in-place party, we want you to know we're going to show up for you. We here at CosmoQuest. In these crazy times, as part of helping us all keep occupied, we're going to be hosting a lot of additional content on our Twitch channel, and we want to remind you that CosmoQuest has an active community on Discord where you can talk science and even find other people to join you in playing some online games. You can find links to everything at cosmoquest.org. Thank you all for being here. Today's script was written by me, Dr. Pamela Gay, and The Daily Space is produced by Susie Murph. The Daily Space is a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are here thanks to the generous contributions of people like you. The best way you can support us is through patreon.com/CosmoQuestX. Like us? Share us. You never know whose life you can change by adding a daily dose of science. And I am now going to hang out and answer your questions. So please set them in and I'll see what I can actually answer. It's dark matter, so we don't have a lot of answers. Okay, I'm going to scroll up to the top and I'm also going to look and see who it is I need to thank because I heard noises. Thank you for the follow, user 736519857. Thank you for the follow, AKS89500. Today we are being joined by numbers. All right, so scrolling up. Going all the way up to the top. Lots of folks saying hello. Oh, man. Oh, thank you, our Instro. I will bring up the dog cam. The dogs already know I'm about to bring up the dog cam. The dogs would like you to know they are ready. Clear that level. Do you want this? You do. Go get it. Stella is so lazy. Thank you. For those of you who are new, we thank you for your bits by giving the dogs Cheerios. So you get thanked with cuteness for every little bit that helps us go. And right now, I know it sucks out there. My husband, he's been 25% time furloughed so that his company can keep going through these hard times. It's not easy right now. And every time you give, it makes it a little bit easier for us to keep things going. And I know a lot of you are furloughed. I know a lot of you are facing layoffs. And the fact that you're here, that alone means a lot. Because sometimes just getting out of bed is hard. Anyways, thank you. Thank you. All the dogs are like, they don't get it. Over there. Go over there. Okay, Eddie gets it. There we go. There we go. Go get it. Thank you so much, Bill Nash, for 18 months of subs. Thank you. Waiting for someone to actually... There she goes. I knew someone would eventually hop up in the chair. All right. So let's see. Fenwell says they had their first confirmed case of COVID at work. Different shift. So we have an emergency shift this morning. Keep yourself as safe as you can. I hope this means that you finally get to start wearing a mask and gloves. Virtual hugs to you, Fenmill. No actual physical contact shall occur till the end of these present times. Hello to so many of you. Hello. There were 4 ads, Larry. I didn't mean for there to be 4 ads. And bathing cats is highly dangerous. Looking to see for questions. Still scrolling for questions. Still scrolling for questions. I got thoroughly mocked for starting without being muted today. Yes, I actually got everything together today. I'm trying to figure out this whole being a professional thing. So Larry, where you write "Darkness for dark times," said the wizard to the hobbit. Is that an actual quote? Which book is that in? Because if that's an actual quote, I need to start using that on things, but I want to attribute it properly. Let's see. 1.0 Acme brick per cubic 1000 AUs. Something like that. Yeah. I don't know exactly what size he used for a solar system, but basically that's how much matter we need. Just like that one brick, the dogs are moving the camera, is all that it takes. Let's see what else we have in here. I have no idea why the word ectoplasm was brought up. I'm not going to try and answer that one. There are so many chair emotes today. So many chair emotes. By which I mean 2. That's just a lot of chair emotes. Neutrinos are very hard to understand. I agree. So Astro Wives asked, how does one weigh oxygen? And I knew this question was going to come up. And I'm just going to have to say, I have no idea. In general, when you weigh things, you weigh them by colliding them off of something and seeing, colliding 2 things that you know the mass of one and measuring the change of angular momentum and regular momentum. You can do this with a pool table, actually. If you roll balls of different sizes with a known velocity, so like shooting them out of a Nerf gun or something. I don't know. That seems like a ridiculous way to do this, but you can actually effectively measure the weight of whatever you have rolled at the known mass of a pool ball by looking at how things do and don't scatter. So in general, you collide things of known mass with known velocities and then see what comes out in terms of movement. I don't know if that's what they're actually doing, and I didn't find the paper and look it up. I'm a bad scientist. But yeah, they're measuring the mass of oxygen. It's a thing. It's a thing. Hello, Commander Unifex. Welcome. He is coming to us from New Zealand. It's a big world out there, and it just keeps going round, round, right, round, round. And I misquoted that. I'm not sure why Bullwinkle is being introduced into the chat. Chat, you confuse. Chat, you confuse. Looking for more questions. Good evening, Guido. I'm so glad your chat is working again. I hope you made the entire thing. And what are you having for dinner, Guido? Because I know you're in the process of thinking about this. Can you warm up London, please? Brexit, you must have the cold that I had last week. This weekend, it actually made it up to the high teens Celsius, the high 60s Fahrenheit, and rumor has it made it actually into the 70s, which would have been like 20 something degrees Celsius. Today we're not there. Today we're like 12 Celsius, I think. Numbers are people too. This is true. Hey. Sorry, I have growl. Hold on one moment. All right. So discussion of temperatures. How bad? The dog's got the camera again. I shall get the dogs. Whoa, Eddie has my speaker attached to his collar. He has my good Bose speaker attached to his collar. I'm just going to end the stream right here, folks. I'm just going to end the stream right here rather abruptly. I am sorry. I need to rescue my speaker. I love you all. I have no clue what the heck is going on. I will raid somebody in just a moment. Good Lord, dog. Ack. Wherever you are in the world, please have a better day than me. Have a fabulous morning, evening, or afternoon. May your dog not end up with your favorite speaker around his neck. Bye-bye.